Next we're going to be talking about urban freight movement. And see if we can get our clicker to work here. Hey, Scott, I'm going to test this out here. All right, I think we might have fixed the situation. All right. Okay. All right, Eren's up next. Eren's spent a lot of time in Europe, at both working in the field and teaching, and now you're at a University of South Florida. He's got a couple degrees in civil engineering and
master's degrees.
Masters, and working on a PhD now. Really, you've been focusing a lot on ITS, freight movement, operations,
yes, exactly.
Traffic volumes, traffic flows.
That's what I'm doing, exactly.
All right.
Yeah, I'm doing my PhD. This is my second year in PhD program. So I'm also international road fellow. I got award from the IRF fellowship program. I was one of two students who belongs to a class of 2019. And now I work with Dr. Bertini. He is my supervisor in the University of South Florida. We are really enjoying visualizing traffic data.
Eren.
Thank you so much, Ed. And thank you, Steve, for the great presentation. And thank you all for showing up today. So today I'm going to talk about urban freight. Actually, this is the title of visualizing urban freight movement by leveraging multiple data portals. Let's get started. So, vehicle classification using traffic flow data is one of the most important parameters in terms of traffic flow, traffic management and operations. And since traffic stream is a dynamic process, it is really essential to visualize this kind of data features for keeping track of traffic movements or instant managements. So what motivated us? We believe that understanding freight behavior can help reduce traffic congestion, especially focusing on major highways such as Interstate 5, can help reduce traffic congestion, air pollution, or freight-related incidents. And currently there are no previous works which analyze and visualize heavy vehicle movements. Our objective was to analyze 20-second length-based vehicle count and speed data to find a better way to visualize those data and to interpret these results. I want to explain our study quarter actually. So this is the Portland, Oregon region. We got 2.5 mile segment on Interstate 5 on Portland, Oregon. The reason why we choose this segment was because there, on the west side of this road, you can see Port of Portland right here consists of lots of ports in it. And also there's an industrial area called Wilsonville Tualatin Industrial Area on the southbound. So on northbound, we had four dual loop detectors and 7 on southbound directions. So let's get deep into the data. The data set we obtained the data from Portal. Portal is a Portland, Oregon Regional Transportation Archive listing, which gets the data using more than 600 inductive loop detectors and share those data with the public for free. We had 3 different types of data sets, which are bin length, bin speed, and average speed data. Bin length data consists of 4 different types of categories, and speed data consists of 10 different types of bin numbers. Each bin number represents a different intervals in terms of either vehicle length or vehicle speed. And we analyzed the days between April 30 and May 6, 2017. We didn't see any holiday major event, and there was a clear weather at that time. Again, length, speed, and speed data. Since we have 2 different types of speed data, we actually wanted to use this data because it gives us more specific detail in terms of average speed rather than giving some speed interval. So how can we ensure that? So we wanted to create a correlation plot to understand if there's a correlation between those two datasets to validate them. And we saw 90% of correlation between those two datasets, and we decided to proceed on using average portal speed dataset. So in this graph, each dot represents the data points corresponding to average vehicle speed and cumulative vehicle length. Here is cumulative vehicle length means since we don't have any real detailed information about the vehicle length, we decided to use mean of each intervals and multiplied each interval length value by the amount of the vehicle and summed them up, and we got the total values in 20-second interval in here. You can see the congested regime in here and the uncongested regime in here. Actually, this is kind of a green shield diagram. It looks like a green shield diagram which tells us average speed here, and normally the green shield diagram has density in here, but we used cumulative length instead of using vehicle count. So it's not surprisingly, we got the same result actually. And as a next step, we decided to cut all these vehicle lengths where they belong. As a category, they are being categories. So, not surprisingly, being one category is more packed and like squeezed in a single area, like from 0 to maybe 90. And the others, the remains are more dispersed compared to the bin category 1. So we found a way to deal with the speed data, but we also needed to find a way to deal with these 4 different kinds of bin categories. So we decided to use FHWA scheme to pack those 4 bins into 2 bins. Using this scheme, we realized that we can use bin number 1 as a passenger cars, bin number 2, 3, and 4 as a heavy vehicle. After that, you can see the passenger car average speed regarding with respect to cumulative length, and these are the truck or heavy vehicle cumulative length with average speed. Now it is easy to distinguish between the uncongested regime with the congested regime in terms of truck existence. So what's next? And then we decided to create another chart for truck percentages and truck volumes. These colorful dots represent an average vehicle speed corresponding to those volumes and percentages. And as you can see, there are some specific areas more packed or more squeezed and in a single specific area. This station called Alberta Street is a upstream direction of this segment, and the next station is Rosa Parks Way. You can see there is another low speed occurs in this volume with this amount of percent of vehicles. This is the next station, it's completely mass. This is the Victoria Boulevard, and the other one is the Marine Drive, which is the closest station on the port of Portland. You can see again the low velocity in here. The problem in here, we can see the truck volume, truck percentage, and the average vehicle speed in this graph. But the problem was when this condition occurs. To deal with that, we decided to create different charts, which are truck volume, truck percentages, and average vehicle speed, and we add them up. We overlap all of them, and we got the new kind of visualization techniques, which is this graph. Now you can this graph shows that each inner circle represents a 500, it increases by 500 truck per hour with 20% of the vehicle truck percentages. With the 5-minute increments of the time, starting from midnight for a whole day, it's just for one station, using with 3 lanes data. Now let's analyze for some of stations on northbound. This is the Alberta Street. You can see lots of ups and downs in terms of track volume, also track percentages. This is the next station. It's Rosa Parks Way. The other one is Victoria Boulevard and the Marine Drive. In here you can see the difference between track percentages and track volumes and when they occur. Actually, this is the station-specific visualization tools for trucks. In each station, we can assign these plots to understand what's going on in this region or on the station. So that we realize that using 5-minute interval data can gives us more detailed information about the average vehicle speed, track volume, and track percentages for each day, for each station. And city and local authorities can use these plots to decide their loading or unloading times on a given specific stations. That's all for today. Thank you all. Thanks so much for listening to me. Any questions? Yes.
I'm sort of curious about the circular plot you're using. I noticed that Chicago uses those to show gunshot violence, and I always find them really confusing. I'm just curious.
If I
you just used
I can turn back actually.
time series plots.
You want me to show the spot right now? I can't change. Can you go back, please?
Yeah, it's just I find them hard to interpret, so maybe I'm not understanding.
The main idea actually, we can create a web-based tool. When we put our cursor on this station, it shows it gives us the ups and downs. Yeah. So you see, actually we see this increasing of track percentage corresponding to reduction of the traffic speed. When we if we create kind of web tools and we put our cursor on this station, we can get the specific detail with respect to all these changes within a given interval. So that, moreover, we can use these kind of plots, maybe we can implement those kind of data, because we have lots of data we train them and we test them. Maybe we can get another next day's prediction. What will happen for tomorrow's condition, so that we can decide whether it's available to drive tomorrow at this specific time or not. It looks like confusing, but whenever it's easy to catch the details for me.
Like I said, I don't understand it when they show the Chicago shootings. I believe that might be overhead.
Okay, I'm gonna check the Chicago state as well.
It's very confusing there too. So
It's actually three-dimensional based on two-dimensional surface, that's why.
Other questions? Have you done anything, the same thing with the passenger side, the inverse there?
No, not yet. But actually, we are trying to find the median length for each bin categories using the occupancy data, convert them to using the average speed data, occupancy, and get the time interval and convert it to the median length for each categories, bin categories. Yes, please.
So, and this is just to understand what the current situation, right? So what
Yes.
we had.
Mm-hmm.
Can you see the potential causes or potential solutions? Like, for example, can you use this to adjust the traffic lighting times to make this better?
So far, our purpose was to create a new kind of visualization plots. But from now on, we are going to focus on how can we alter the driver's loading or unloading times using actually machine learning to let them know, hey, there's going to be a problem tomorrow. There's a 90% of problem you'll see tomorrow at this time specific interval. And actually, I use recurrent neural network to train this data, and I got pretty good, promising results. Actually, we can, maybe for my next research, it's going to be about the machine learning, predicting this kind of plots using machine learning. Yes, please.
Eren, to the Steven's point, going through the basics of visualization, they should not be confusing. And one reason is too many variables on a single plot. So I would suggest you either remove the trend percentage or the trend volume, and maybe it's the length of the trend volume, because trend percentage is a bad explanatory variable, which is a percentage of total traffic, traffic in relation to all traffic, correct?
Yeah.
So it then shows that, especially this, if you look during the congested period between 2 p.m. and about 6.
Yeah, 6 to 6:30.
You see the, for example, the thread percentage is relatively low and still congested, which is to say the overall traffic, which creates congestion, not just thread traffic.
Absolutely, yeah, you're right. This is a peak hour.
Yeah, it's important to know that these spikes when the absolute thread volume is higher, but probably it's too much for a single traffic, and for other users you may want to use the kind of if you create a
web-based tools.
Web-based tool to have the same maybe presented so the user can use the one that is kind of straight.
Yeah. That would be great. I mean, that we can definitely do that. So let's say we can put some explanatory variables near of this graph. When you click, I want to just see the track volume. Just click it, and just this track volume appears, and then the other. Yeah, and the other problem, not problem, but the condition of the Portland, Oregon region, especially the Port of Portland, they have lots of truck density. Comes from the north, because I-5 is the major highway which connects from Canada to Mexico on a single line, and there's a high truck density on it. So it's not surprising to this. At this point, it might be a little bit confusing, but I believe that if we can find another data and implement truck percentage and volumes on it, we will see more clear visualization tools. It's because of the regional problem, I believe. Thank you.
All right. Thanks,
Thank you.
Thanks, Eren.